Chapter 6, Looping Part 3. One of the things loops are really good at is validating data. Let's take the password example again. You want to give your user a second chance to get their password right, maybe even a third chance, because it's frequent that users will make typos. So if we want to keep prompting the user to give them another chance, we have to do something with our loop control condition, because we want to test whether or not they entered their password correctly. But we have to use that variable as the loop control condition, but what value is it going to have before the user enters it the first time? So when we prompt for input, before we test what that input is, it's called a priming read. Now, this is just like priming a pump or priming your lawnmower before you start it up. It's putting a value in there so you have something to test before you enter the loop. Here's an example. So if we say user entry equals input.nextInt, we're putting an initial value into that variable user entry before we test it. And then we say while user entry is greater than limit. So when the user enters a number that's over the limit, then we say, nah, it was too high, you got to try that again. And then we say user entry equals input.nextInt. And that's our update of that field. Notice the three parts of the loop. The initialization, which is the priming read in this case, user entry equals input.nextInt. There's the testing, user input greater than limit. And there's the update. Down at the bottom of the loop, we're getting a new value for user entry before we go back up to test again. Using shortcut arithmetic, it's pretty handy. You've seen how we have, I forget what it was called, loop count equals loop count plus 1. That's a lot of typing. We can shorten it up by using a shortcut addition operator. So we could say loop count plus equals 1 rather than saying loop count equals loop count plus 1. It's less typing. We also have the minus equals, the multiply equals, the divide equals, and the modulus equals. Rarely have I seen the modulus equals use the remainder and assignment operator, but frequently we use the add and assign and the subtract and assign. Some other shortcut arithmetic operators that are handy in this case are the plus plus and the, I don't see it, but there's also a minus minus. The plus plus operator is the increment operator. It will increment an integer variable by 1. So plus plus some value will increase whatever's stored in some value by 1. Some value plus plus will do the same thing. It will increase it by 1. There's a difference between the prefix, that's putting the plus plus before the variable name, and the postfix, that's putting the variable after the variable name. And we'll take a look at that in just a second. So if we have an example here, int value, and we set value equal to 24. If we say plus plus value, now value has 25. Then we reset value, value equals 24. And then we say value plus plus, and again it equals 25. And then let's reset value, set value back to 24. And if we say value equals value plus 1, the result is 25. Notice how much more typing that is than just saying value plus plus. And also, value plus plus is slightly more memory efficient than saying value equals value plus 1. Another example, so we see the increment operator there, plus plus, and then down at the bottom, the last line in this example in figure 6-13 is value plus equals 1. That's also used quite a bit in addition to plus plus. Plus equals 1 will take what's in value, add 1 to it, and store the result back in value. In this case, with value plus equals 1, we could put any number out there to the right hand side. We could say value plus equals 5, and that would increase value by 5. That's not true with the increment and decrement operators. With plus plus, it only adds 1, but with plus equals, it'll add whatever we tell it to. So the prefix version of the increment operator, adds 1 before the variable is used in whatever statement it's currently in. The postfix adds 1 after the value is used in whatever statement it's in. We'll see an example in the next slide. We've been talking about the increment operators only. There's also a decrement operator, minus minus. It works the exact same way. Instead of adding 1, it subtracts 1. So let's take a look at this. We've got int my number and answer. We set my number equal to 17, and we say before incrementing, my number is, and that will print out 17. And then we say answer equals plus plus my number. Now that's the prefix version of the increment operator. So we'll add 1 to my number, so my number will become 18, and then it will store that 18 inside answer. So we say after a prefix increment, my number is, and it's going to be 18. And answer is, and it's going to be 18 because it was the prefix operator. Let's reset my number to 17 and try it the other way. Before incrementing, my number is, and it'll say 17. And then we say answer equals my number plus plus. With the postfix version of the increment operator, instead of the prefix version, it uses the number first and then adds. So answer equals 17, and then my number plus plus will make my number 18. So in this case, answer is 17, but my number is 18. So they're different. In the first case, they were both 18. In the second case, answer is 17, and my number is 18. If that's confusing at all to you, I encourage you to just pause right here, type up this little program in NetBeans, and run it, and see what you get. Even if it's not confusing to you, I encourage you to just pause, type this up and run it, because there's no substitute from working with the code. It'll take you 5 to 10 minutes, and it will help you understand this much more clearly.